How's it going, everyone? Welcome, Elviro Gonzalez here, and today we're going to now explore the corner cases and the philosophy of coercion, right? So the idea of making this quick recap is to understand now these three pillars of JavaScript, because at the end of the day, this is the only profession that JavaScript developers are known as professional guessers. Imagine that you're getting paid for doing that, for being a professional guesser. Imagine that you are an architect and then you are guessing what the dimension, the distance of a column should be, right? Of course, that will, if you don't do that correctly, that will now is falling apart and kill a lot of people. So the idea is to be much more competent when we use this particular tool, and therefore there are three pillars that we need to know about this language. So the first is the type system, something that we have to look, and we're gonna dive deep into this topic, where we look at the values, the different type of values, the special cases of values, the kind of emptiness, as well as the abstract operations, okay? And the most common abstract operations. So we are also quite familiar with the spec, all right? This is also an idea of why we need to read the spec, and we're going to become much more proficient at doing that. So understanding is the abstract operations, all right, and then the philosophy of that. So we went through the scribe is this is just only the type system as well as the philosophy behind coercion. Now, then we also going to look at the scope, such as function expressions and block scope and lexical scope, and so on, so on, and the objects oriented. So first thing first, sorry, first thing first, we went through the type system to understand what is the different type, what is the primitive, and the ECMAScript values, whether it's primitive and objects, and also now to understand what is the list of values that we can get when we use a primitive, right, or the objects, right, such as undefined. When you use, for example, type of, so type of with undefined or null or a boolean to get the value out of variable, right? The boolean, the number, the string, the symbol, the big int, as well as the object. In some corner cases here, for example, with null, and why when you want to get the value of a null, it gives you an object. And for historical reasons, in the EX61, if you want to unset a variable, you use a primitive, you use undefined. But if you want to unset a reference in memory, aka an object, you use null. This is the reason why it gives you now an object type when you want to evaluate. The thing here is that this is a bug. You have to be careful with this. And another corner case, which this is more for computers, classical computers, such as adding 0.1 and 0.3, because decimal cannot accurately, or because the numeric representation, the binary representation cannot accurately describe is the 0.3, and also in the decimal you cannot describe is the division between 1 by 3, because it gives you now 0.3.3333333, and because we have now a limit memory in our computers, so language sorry, so language or computers actually round that number So when you use, for example, 0.1, 0.2, it's actually round those numbers, and therefore when you are trying to get that value, you get this 0.1 plus 0.2, you get now 0.30004, right? And it's because it's this limitation of the computers when it comes to store data, and the representation of a numeric value like 0.3, which is not accurate, all right, given the nature of that operation, 1 divided by 3, and therefore you have now this need to put a particular length of this sequence of this number here, and therefore, well, you have to round that. So that's a very interesting stuff, because how you can solve that is by wrapping that into a number and say, hey, only give me the two decimal points, right, after the give me the 2 digits after the comma, the cents. And I think this is quite interesting because we also recognize is the limit of our knowledge in the computer science, all right? And this is also very interesting questions to ask for a senior developer, right? Good. Then I look at the special cases of the, for example, how do you call it, with like NaN and positive and negative zero, all right, as well as big int, right? So big int is the only value that is not being coerced, and NaN is the only type. Sorry, is the only type that is not being coerced, and NaN is the only value that is not equal to itself, right? So NaN, at the end of the day, is that it means that the number that you're trying to describe, that you want to use, is not a valid representation in this spec made by the Institute of Electric and Electronic Engineering, and they create this spec, the 7054, where it now set the rules of how many numbers can we represent here. And this is followed by a 2 power 53, which is like a 9 followed by 15 digits. So we can represent now a quadrillion of that. And I think this is important to understand this notion and why big N actually kicks in, especially for cryptography, or when you need to express huge numbers, like for example, like astronomical distance, right? Or in the financial world, when you need precision here. So in other words, and in any case, we also look at how can we check the NaN, the positive and negative zeros, some particular use case and some example of how can we do that, and then the abstract operations, which say, or which tells the language how it's going to handle the type conversion. We look at the most common type conversions or abstract operation because there is several that conceptually we can have access to these methods, but conceptually we can think of this is what's going on when JavaScript tried to figuring out the type of those values, right? So you have now the primitive, to primitive, which is now is trying to coerce that or to convert that into a primitive, whether it's a number of a string, all right? And if it's a string, it receives now a hint as a string, and it's going to perform is the to string, and if it's not, the to value of, right? And vice versa in the case of numbers. So for transforming a primitive value, so far so good. So there is no big deal in doing that. Let me show you this. There is no big deal here. All right. So it's trying to coerce that into one of those primitives, as I mentioned before, right? Whether it is a number or a string or an undefined yada yada yada. The other abstract operation is the toString, which is kind of intuitive, right? So anytime that you pass now, for example, a number to here or a primitive, okay, anytime that you pass now a primitive, it's going to transform that correctly into a string, except for -0, right? This is the stringification of primitive. But what about stringifications of objects such as arrays or such as array or objects, right? So for arrays, they give you now an empty thing. If you pass the value, they give you now the value in a stringified way. And if you pass null and undefined, give you now this. Not to mention that if you pass this or this, right? But when it comes to object, it gives you now this square brackets called the object, which is kind of counterintuitive that they include now the bracket here and not here. But in any case, you can also override the behavior of the toString and give you now a more meaningful value. This is something that you're not going to do a lot in the programming. It's useful to know. You might need to use at some point, perhaps. But this is what happens when you want to stringify is a primitive or an object. What about if you want to use the two-number abstract operation, right? This numeric operation here that is the numberifications of primitive or string, okay? This is the numberification, if that word exists, of a string. So, if you take now a string, an empty string, it becomes a 0, and here is where the stuff it becomes the prop. So when empty string becomes the root of all evil, you're gonna see that why. So it actually transformed that properly, okay? So the numberification of a string, the numberification of booleans, all right? So false is 0, true is 1, num is 0, and undefined is nan. I don't know why they don't put here nan as null, but in any case, you're going to see that also. And then you have now the numberification of an object, which is, as you might guess, nan, right? So for objects is nan, but for arrays is now a 0. If this is an empty array, if this is a 0, it has a 0, it's going to show you a 0. If this is null, it gives you 0. And this is undefined, it gives you 0. And what's happening here is that it's trying to coerce this into a string first, because it's calling the two-number, and if cannot convert that into something, then it's going to pass that into a string. So the other is a two-boolean. Two-boolean is unlike the two-primitive and two-string, is not algorithm, is a lookup table where you can memorize what are the falsy values. As long as you know that empty string, nan, false, undefined, null, and positive or negative 0, all of them will give you false, and anything else is true. In other words, empty strings are true, or white space strings are true. Okay, so you can even pass now an array, and that will be considered as a true. So two boolean is any place where you are using when you don't need a boolean, but a boolean is required in that field, this operation happens. So in other words, if you say something like this, unfortunately, this is going to be evaluated as true, and they say, uh-oh. You know? This is when now things actually happen. And I love to use these kind of cases, okay? Because for this case, it makes a lot of sense. All right? So if this is an empty array, all right, it is true. That might be what you want to, all right? If this is an empty string, so it is false, all right? So it never get into here, okay? But there are some use in corner cases, and that's when we look at coercion, where now the algorithm of coercion, give preference to whoever, to a string concatenation, and then number operations. So this is something you can take a look at. Check that out. I will allow you to go with. And this is some couple example here. So you think that coercion is something that you don't need to learn, but you are using coercion in template string. When you are now on template strings, or when you are going to pass now a value to a function, and you want to coerce that, a numeric value, use a plus number for that. So in my case, this might be sometimes useful. This is what you want, to be explicit about this, okay? Or sometimes you want to be explicit about what is the number, what is the type of this value that you want to pass here, such as with numbers, all right? Or for Boolean operations, okay? So for example, like if or while, right? So you want to now coerce that value, whatever value it is, into a Boolean, for example, like this. But you have to be careful that, remember, empty strings are false, okay? And not to mention that lines are true. You know what it means? So the idea here is that is to be more intention about how we're gonna use this type coercion. At least it's most common operations: the two string, the two number, and the two Boolean. And there is a concept called boxing, which say, hey, JavaScript actually wrap an object when it does this type coercion, and it is called boxing. This is known as what everything in JavaScript is an object, but it's not true, because what it does is to wrap this into an object when it does a type coercion, right? So all programming languages have a type conversion, and because it is absolutely necessary to know about this. And then we look at the corner cases of coercion, like this. So you have the number. When you pass in a string, okay. Corner cases of numbers. So for example, that's interesting. Where you say, hey, is this a number? This is supposed to say, hey, this is nen. Let me see, is this is 0? That's interesting. If you pass now, this is part of, okay, the corner cases, the numberification of a string, okay? If you pass now an empty string, it becomes 0. If you pass now line break, it becomes 0. If you pass null, it becomes 0. If you pass undefined, it becomes nen. What? If you pass now a number And an empty array, which is now, this is the string, the numberification of objects here, which is something that we don't mention here, but it's important. The numberification of a string, empty string is 0, lines or nulls and undefined is nan. An empty string here, or the numberification of objects, it gives you 0. This is nan. This is 0. This is 0. And if you pass an object, this is nan. Now the stringifications of primitive, all right, -0 is 0. Null is null. Undefined is undefined. You know, you already developed this intuition. When this is an array, I think this is an empty, exactly. Or an undefined, this is an empty. And also you have to be careful about doing this. Boolean. The new Boolean false. So if you initialize a new instance with false, it say, hey, yes, this is a new instance of false. And also is the root of all coercion evil. Remember that empty string, okay? If you pass not into a number, it is 0, okay? If you pass a break line or an empty line, it is 0, okay? So if you want to, for example, validate an input, right? And the other is, well, the non-verification of booleans, true, 1, false, 0, actually following that logic. And when you do now comparison here, there are some corner cases that happen here. And this is because it evaluates this expression and transform into a Boolean, the type coercion. This is one of the reasons why this is the comparison operators and what they produce, all right? So with these corner cases, now let's take a look at the philosophy of coercion. Let's take a philosophy of coercion. Let's get into this.
So there are corner cases. We know that that's a reality. There are corner cases. You don't deal with corner cases in any language, but least of all JavaScript, by simply avoiding.
You don't deal with this type of conversion corner cases by avoiding coercion. And I think,
You don't avoid the whole mechanism just to get around a couple of corner cases. You have to adapt a coding style that makes your types and the values that are in those types plain and obvious. That's the only effective way to do this. Some people go so far as to use whole type systems, and we'll get into that a little bit later, like TypeScript and stuff. I don't think you have to go that far, but you can adopt a coding style which makes the kinds of types that you're doing much more obvious. I make the claim that quality JavaScript program is going to have to embrace coercion. You have to make sure that the types involved in every operation are clear. And by the way, that means that you shouldn't be designing all these polymorphic functions that can take any sort of value and do 15 different things based upon the value. You're asking for coercion problems when you do that, and then papering over them, but, oh, I use the triple equals. Why not just design a function that only takes numbers, and then make another function that only takes strings? Or make a function that takes numbers and strings, and it's very clear it can only be those two types, and I know what corner cases I have to worry about between numbers and strings. We can choose to be more obvious about how we manage our types, how much we overload, how polymorphic we make our code. We can opt into more problems or opt out of problems as a result. Biggest takeaway that I want you to get here is that these are a fact of your programs, and it is within your purview to decide how much or how little you're going to be affected by those facts. That is not to suggest that the only solution to our problem is that everything have to be rigidly, everything's completely statically typed. We have to just basically go write Java or C++ so that we get some kind of like sound type system. That is a reaction to this problem. It is not the reaction I think that is necessary. So the message I'm preaching here is you can learn these systems, use them appropriately, and make them obvious in your code. I do not think that these typing systems are weaknesses. I actually think this is one of JavaScript's strongest qualities. It's an unsung hero. I think it's one of the reasons why JavaScript is the ubiquitous language that it is today.
JavaScript dynamic typing is not a weakness. It's one of its strong qualities.
Because it has been so palatable to so many different use cases. The first truly multi-paradigm language, and a big reason why it has been able to survive multi-paradigm, is because of its type system. And that's completely opposite from what every one of my peers and everything else that you've ever heard. Everybody else has always told you this is the worst part of JavaScript, and I'm going to put my foot down and say it's one of the best parts of JavaScript. And if you're not using it, your programs are missing out. And the argument I always get back from people, and some of you may be thinking this at this moment, is, yeah, but even if I sat through your workshop and I learned all these nuances and I read the spec, what about all the junior devs on my code base? They would never understand this stuff. This actually infuriates me almost more than any question I ever get. This mindset that says, well, I'm smart enough, but those junior devs, they're too dumb to understand this stuff. That is complete and total nonsense. I don't know what your backgrounds are, but every one of you is excellent at what you do. You may know more or less about JavaScript, but that doesn't make you dumber.
Intentional coercion, man. Intentional coercion, man. Intentional coercion. Yeah, man, absolutely. Absolutely. Absolutely, man. It's a culture of learning. And that you have it. It's like,
And less capable of understanding stuff, less capable of learning things. I do not subscribe to the belief that we should dumb down our code bases to the lowest common denominator. You should absolutely use the tools as effectively as you can. Mm-hmm. You should be as obvious about how you're using the tools as possible. And when somebody is on the code base who doesn't understand, use it as an opportunity for them to learn. Use code reviews, use a culture of peer-to-peer learning,
exactly.
Of pairing together, exactly. All of those things to help everybody learn how the tool works better. Mm-hmm. When you receive a code review and some junior developer did something dumb, like they didn't do a coercion correct, and maybe there's some corner case they didn't know about, you don't reject the code review and say you're dumb. You say, hey, come sit with me for a minute. Let me just talk to you about this corner case that you weren't aware of. And if you did this thing instead, we'd avoid that corner case entirely. Now you learned better and they learned better. This is a complete bunk argument. It's a lazy excuse for not wanting to actually do what we ought to do on our developer teams, which is promote that everybody should be learning. Everybody should be headed upward. I don't care where you are. I care what your direction is. Are you headed upward? Are you learning more about your tool? This is not an excuse for not using the tool as well. It is also not an excuse for being clever, right? Some people say, oh, well, the slippery slope argument here, I can just do all this like clever bitwise math, right? I'm using the tool and upper, right? Some people say, oh, well, the slippery slope argument here, I can just do all this like clever bitwise math, right? I'm using the tool and I'm being clever and I'm doing all of my programming on one line of code the way we used to do in Perl. That's not what I'm saying either. What I'm actually saying is that your code is a form of communication, and there is an effective way to communicate that understands and uses the tool well.
The code is a form of communication, and you must use your tool to be effective with it.
If you ask the reader of a code to understand something about the tool so that they can understand that line of code, that is an investment on their part. Make sure that that investment pays off beyond that line of code. Make sure that when they learn how that worked, they're going to see more of that, rather than make sure that that investment pays off beyond that line of code. Understand something about the tool so that they can understand, communicate that understands and uses the tool well. If you ask the reader of a code to understand something about the tool so that they can understand that line of code, that is an investment on their part.
So if you ask a person to understand your code, if you ask a person to understand your code, make use Make sure that that investment pays off, bro. Make sure that investment pays off. So if you ask a person to understand your code, make sure that investment pays off, bro. Beyond the line of code. Beyond the line of code.
Make sure that that investment pays off beyond that line of code. Make sure that when they learn how that worked, they're going to see more of that rather.
So make sure exactly that when you see that particular pattern, you know what's going on. Make sure that when they know how that works, they see the pattern and identify. They see the pattern, identify them, and effectively, they see the pattern and effectively communicate the code.
Rather than they learn how you did some weird esoteric bitwise trick.
Identify them and effectively. So make sure when they know how that works, they see the pattern, identify them, they see the patterns, rather than showing some esoteric bitwise operations you made. In other words, make it simple for yourself.
And then they never get to use that ever again. That's a waste of their time. Makes you feel good, but it's a waste of the time. And it's part of the reason why we struggle so much to have good dev culture. Because we're not focused on promoting that everybody should be able to understand. From the person who is 3 weeks into JavaScript to somebody who's been at it for 20 plus years like me, we all ought to be able to interoperate on the same code base and communicate well. Yeah, the junior dev's going to need to learn some stuff, but that's what happens in every job and in every industry. You have to learn some stuff. You don't see an architect saying, well, we're not going to design that building well because we've got an intern on the job. You teach the intern how to build the building well. That's what we need to be doing. We need to be doing it with all parts of JavaScript, but especially the parts that everybody tells you to ignore, like types.
I'm curious what the role of something like JSDoc or other notation standards are. I'm curious what the role of something like JSDoc or other. I'm curious what the role of something like JSDoc or other notation standards are. It kind of sounds like there's the issue of writing code for the machine and then writing code for the humans who have to read it. Weeks down the road. And I'm very persuaded by the arguments about, say, for using explicit coercion. But are there other cases where you have encountered or would recommend ancillary tactics like that?
Well, I certainly think if you think about coding on the whole, it's a great question, by the way. If you think about coding on the whole as a way to communicate my ideas, then there are lots of ways to communicate ideas. One of the ways is in the code that you write. One of the ways is in the ancillary stuff that you mentioned, like, for example, code comments. Now, some people tell you, no, you should never need code comments. Code should explain itself. You should not have more reliance upon code comments than the code. And I've seen code bases that are like that are so inscrutable that without the code comment, nobody's figuring it out. But code comments are not a bad thing to be avoided. They're not exposing some weakness of the program. Here's the problem with code comments. People write the what in their code comment. I'm sorry, they write the how in their code comment. Like, you have a line that says I++, and then you say something like increment I is the code comment. I know it's incrementing I can see that. Here's what I want the code comment to tell me. Why? Why do you need to increment? And why only by 1? Why not by 2 or 12? Tell me why. And sometimes maybe tell me how, but don't tell me what. That's what the code's for. Exactly. So yes, you can communicate well with your code. If you did a JSDoc on this function and said these two parameters receive either strings or numbers, then you're very clearly signaling to everybody, be aware that some coercion may happen, but it's only between strings and numbers. And so we know we have narrowed down the scope of corner cases that we need to be concerned about. Absolutely, code comments can be useful. I wouldn't rely entirely on them. I think there's lots of things we can do in our code to be obvious.
So in other words, it's like use comments for.
There is a temptation to believe, and sort of a cult feeling among the community. Most developers tend to think that implicit mechanisms are magical. That when something happens underneath the scenes and it wasn't obvious, then it's some sort of magic, and we tend to equate magic with bad. evil. Like this is not good because I can't understand what's happening. And this is a predominant reason why that anti-coercion perspective exists, is because people feel like the implicitness of coercion is the downfall, where they point to the explicitness of typecasting in something like Java or C++, and then they say you would never like automatically convert an integer into a float or whatever, but JavaScript does all this sort of automatic stuff, and then they say, well, that's a weakness of JavaScript, so because it's magical and bad. I don't think it's either of those things. I think that we should think about implicitness as abstraction. Not all abstractions are good, but some abstractions are necessary. Implicitness, and we're not dealing with functional programming here. This is not this course. That's a different course. Here's a plug. You can check out my functional programming course. But within functional programming, you use abstraction all over the place. And it turns out that the declarative style of coding is actually more implicit. So implicitness is not bad. It is the proper usage of abstraction. In other words, we want to hide key unnecessary details. Why? Because that refocuses the reader on the important stuff. We're not distracting them with the stuff that they don't need. We want to focus them. We want to increase the clarity of the code by refocusing. So some of the implicit nature of JavaScript's type system is sketchy, but some of it is quite useful. For example, the boxing, that's implicit, but also very useful because the distraction of having to cast it into an object isn't, what I would argue, in most cases, an unnecessary detail that the reader doesn't need.
The boxing, some of them
And
are
that's
sketchy.
actually at the DNA of JavaScript.
Some of them are
Part of the
useful.
reason JavaScript has such a low barrier to entry is because it doesn't force the reader to deal with a bunch of unnecessary detail. It betrays JavaScript's DNA to suggest that all those implicit things are things that we should avoid. So here, if I'm writing string to make it super obvious that I'm going to make this thing into a string, I don't know, I think that's distracting. I think I would just drop in the number and be perfectly happy because I know that number is never in any of those corner cases where something could be weird. Maybe I've already checked to make sure that num students is not nan, for example. All the other numbers that it could possibly be other than -0 and nan, those are my only corner cases that I need to worry about here. So if I have if statements that deal with those corner cases, then this line of code, line 4, is actually better communication because it properly lets JavaScript abstract the detail that's not necessary to deal with at that moment. Here's another example. The less than operator, we talked about how it coerces things into numbers. Sometimes you want to go ahead and make sure that both of them are a number so that you don't get something weird. For example, if both of them are strings, it doesn't turn them both into numbers. The less than operator does an alphanumeric comparison. So there's a corner case. If you could possibly have a less than applied to two strings, you probably do want to make sure that they're both numbers first. But if I'm in a place of the code where I know at least one of them is definitely a number, well, then I know the other one's going to become a number. So maybe it's not necessary to force you to read the fact that I'm making them both numbers. Maybe it's okay to let that less than operator do the coercion for me. These are not hard and fast rules. These are trying to train you to think like this, to analyze. And if you are in a place where you have the choice to use coercion, but it's not obvious, it's within your purview to make it obvious. Make it obvious that they're both numbers, and therefore I don't need to worry about like explicitly casting them. It's just already obvious that they're both numbers. If you communicate that intent, it's not going to trip up other readers of the code. Really, the question is showing these extra details helpful to the reader or not? Sometimes yes. Sometimes
I think
no.
it is. It does.
Basically, I'm asking you to be critical, analytical thinkers. To be an engineer and not a code monkey. Okay? Doug Crockford famously said, if a feature is sometimes useful and sometimes dangerous, and if there's a better option, then always use the better option. As a matter of fact, almost all of the good parts stems from this one foundational perspective. I respect what Doug has done for our industry, but I couldn't disagree more with this perspective. Partially, I disagree with this because we throw this principle around and we don't even say what we mean by these words. So what is useful and what is dangerous? Only what Doug thinks is useful and dangerous? Is there some universal definition for useful and dangerous? How about better option? How do we define better option? Is there some universal standard by which we measure better? This statement is not useful in its abstract sense. It's used in its abstract sense, but it's not useful. So let me put my mark in the sand and tell you what I mean by those words, okay? Number one, useful is when the reader is focused on what's important. And dangerous is when the reader can't tell what's going to happen. And better is when the reader understands the code. So you could take that principle and apply
So
this
useful is
specific...
when the reader is focused on what's important. Dangerous when the reader can tell what will happen. When the reader can tell what will happen. And better is when the reader understands the code.
meaning to it, but you can't simply
It
throw
is
that sentence
dangerous
around
because
as a
you can't tell what will
justification for
happen.
why you avoid learning an entire part of the language.
It's part of this forecasting work.
The big crux here is, in Doug's opinion, there's a better option, which is just don't learn and understand types. My perspective is that's not better at all, because it leads to developers systemically not understanding their code. It's not better because it leads to less understanding. The takeaway I want you to get here is that it is irresponsible to knowingly avoid usage of either code. It's not better because it leads to less understanding. The takeaway I want you to get here is that it is irresponsible to knowingly avoid usage of a feature that can and does improve code readability. It is not just simply you're not taking advantage of some great things. You are actually making code worse off. Not only for your future self, but for all other people that need to read and maintain your code. A tool exists, and it's irresponsible not to learn and use it. Let's take a look at coercion a bit more deeply with this exercise. We've learned now a bit about how coercion works with, different operators like the less than operator and things like that. So we want to do some validation functions to make sure that some inputs that are coming, like for example on a web page that were coming from DOM inputs, we want to make sure that some inputs that the user is giving to us are valid. So we're going to define two different validator functions. The first one's called isValidName. Doug Crockford famously said,
Understanding feature.
if a feature is sometimes useful and sometimes dangerous, and if there's a better option, then always use the better option. As a matter of fact, almost all of the good parts stems from this one foundational perspective.
And pay for it.
I respect what Doug has done for our industry, but I couldn't disagree more with this perspective. Partially, I disagree with this because we throw this principle around and we don't even say what we mean by these words. So what is useful and what is dangerous? Only what Doug thinks is useful and dangerous? Is there some universal definition for useful and dangerous? How about better option? How do we define better option? Is there some universal standard by which we measure better? This statement is not useful in its abstract sense. I'll tell you what I mean by those words. Okay? Number one, useful is when... So, let me put my mark in the sand and tell you what I mean by those words. Okay? Number one, useful is when the reader is focused on what's important. And dangerous is when the reader can't tell what's going to happen. And better is when the reader understands the code. So you could take that principle and apply this specific meaning to it, but you can't simply throw that sentence around as a justification for why you avoid learning an entire part of
what's
it.
important. Dangerous is when you can't predict what's going to happen. And that's dangerous, especially here you're building
there's a
this kind
better
of
option,
stuff.
which is just
And
don't
better
learn and understand.
is when the reader
My perspective
understands the
is that's not
code.
better at all, because it leads to developers systemically not understanding their code. It's not better because it leads to less understanding. The takeaway I want you to get here is that it is irresponsible to knowingly avoid usage of a feature that can and does improve code readability. It is not just simply you're not taking advantage of some great things. You are actually making code worse off. Not only for your future self, but for all other people that need to read and maintain your code. A tool exists, and it's irresponsible not to learn and use it. Let's take a look at coercion a bit more deeply with this exercise. We've learned now a bit about how coercion works with,
eu vou, este logo, e colocar uma maior festa junina fora do Brasil. Onde só diz festa junina, quando empeça, tem que figurar o nome da associação e o logo da festa. Eu já mandei o logo para ele e ele vai colocar. E aí nós subimos, ok? Bueno, já vai haver novidade para duas apresentações mais. Bueno, claro. E eu pedi a ele para colocar o logo, festa junina, ele leva que eu vou, este logo, e Diego está haciendo lunes y miércoles. Porque está yendo a dos clases, a una y otra dentro de la semana. Y yo, martes, tres viernes, hace la cosa, y Andrés, que se ahorita que vengan las vacaciones, los voy a meter con. Niños, bueno, pero esperemos. Ahorita lo que estoy es con un nutriólogo, con un plan alimenticio.
Different operators like the less than operator and things like that. So we want to do some validation functions to make sure that some inputs that are coming, like for example on a web page that were coming from DOM inputs, we want to make sure that some inputs that the user is giving to us are valid. So we're going to define two different validator functions. The first one's called isValidName, and it gives the requirements here. It needs to take a string that is non-empty, must contain something that's not white space, and has to be at least 3 characters long. Okay? So it has that find with, take a look at coercion a bit more deeply with this exercise. We've learned now a bit about how coercion works with, different operators like the less than operator.
Exactly, like that.
So we want to do some validation functions to make sure that some inputs that are coming, like for example on a web page that were coming from DOM inputs, we want to make sure that some inputs that the user is giving to us are valid. So we're going to define two different validator functions. The first one's called isValidName, and it gives the requirements here. It needs to take a string that is non-empty, must contain something that's not white space, and has to be at least 3 characters long. Okay? So it has to return true if what you pass in matches that, and otherwise return false.
And this is a very basic
Again, the spirit of
stuff.
this exercise is
This is
what
very
we learned
basic
now
stuff that
about
you're gonna do
coercion
a
to
lot.
properly handle. A variety of
Oh my
ways to
God.
do it, but try to properly handle that check. Then you're going to do a slightly more complex validator called hours attended. It takes 2 inputs. We'll call them attended and length. It allows either one of these to be a string or a number. So we are going to allow a bit of coercion here. We're not going to say it has to always be a number. We'll allow both strings and numbers, but nothing else. So we need to check to make sure or assume that those are definitely strings and numbers. Whether they come in as numbers or not, we're going to treat them as numbers. So this is not a case where we throw an assertion if you pass it wrong. We're just going to say the contract here is you got to pass this a string and a number, and then treat it as a number. Those numbers have to be 0 or higher, so no negative numbers. And also they have to be whole numbers. We don't want to pass in something like 3.14. Okay?
Exactly.
And then finally, attended has to be less than or equal to length. So those are your two validators that you're going to define, trying to practice what we've learned so far about coercion. We'll take about 10 minutes on this. As you can see in the exercise file, we have console.log statements, which are our test cases, essentially. This is the poor man's approach to testing, if you will. So all these console log statements should print true if your functions are correct. Define those two functions, drop this code into your favorite console, or run it in Node, and you should get it printing all trues. Take about 10 minutes for this exercise, and then we'll come back and talk about the solution. Okay, welcome back from the coercion exercise. Hopefully you found that an interesting challenge. Let's start. Again, remember the README says we want an isValid name function.
Valid here.
So we'll start by defining
So is this
valid
valid
name. It needs to take a
function here?
name.
And
It needs to assert several
And
things.
here we're
First
gonna
off,
assert
that it is a
if
string.
it is a string.
Secondly, that it contains
That
at
it
least
can
something
contain at
that's
least
not
something that
only
is
white
not a
space.
white space,
And
exactly.
the stuff that it contains that's not white
At
space
least
has to
must
be
have
at least 3 characters long.
3 characters.
Okay? So first off, we want to make sure that the
That
type of
the name is equal to string.
Here I'm using the double equals with the type of operator because we know that the type of operator always returns
Returns a
strings.
string.
And we know that it always returns non-empty strings, so we know we're safely out of the corner cases.
So if this is a
So
string,
if type of name is equal to string, and we also want to make sure that we don't
That we
consider
don't receive any white space.
only white space that may be in
We
the
can
string
string
in terms
that.
of our length check, that is. So one
So
built-in
there
way to
is
do
a
that with
built-in
JavaScript
property
strings
here
is the trim.
that is the trim.
The trim method.
Which
So
is
we can
the-
say if name.trim, which trims off any white space from either side, and if what is left is at least of length 3, then we know we have a valid string.
Exactly.
Did I use greater than or greater than? Yeah, sorry, greater than or equal to 3. Okay? In that case, we want to return true, and otherwise we can return false. Now, you could simplify this a little bit to simply return that expression if that's your preference. You could not have an if statement here, just being illustrative of the decision making that we make, which is
Exactly.
are we in
Just
a
to
success
return the
condition,
decision
great,
making
we
here is
return
hey,
true,
I want to
otherwise
take
we're not.
if this is a type of
So if we just
a
test this right away,
string
we should
and
get
is the name
that test to
string.
pass, and we should get these 6 tests to pass, and everything else should fail. I don't want to get errors, so I'm going to just define an hours attended
with
and have
nothing
it
here.
return
It
nothing for
returns
us. So all the
undefined.
rest of those should fail. So let's try over in the console. Again, you could run that via Node if that feels more comfortable to you, but let's run it over here in the console, and let's see if it prints out the results that we're expecting. So the first test returns true, which is good, and then we have several failures, 4 failures, and then we have 1, 2, 3, 4, 5, 6 successes. So we see that isValid name is passing our test suite. Okay, that's good progress. Let's move on to hours
Move on
attended.
to the hours attended.
This one was a little bit more complex, but not significantly so. It takes in 2 parameters. Remember, we're going to call those
The
attended,
attended
meaning the
and
number of
the-
hours that you attended a
the number
workshop,
attended.
and the length of the workshop. And we're trying to make sure that what was inputted is valid, that you attended not more hours than the workshop actually attended. You don't want to get extra credit there. So the README says we want to make sure that these are either strings or numbers, and that regardless of which one they are, we're going to treat them as numbers. So if
Exactly. So if
the attended is
a
a string, then we want to turn it into a number.
we're gonna turn it into a
Okay,
number.
so first off, we could say if the type,
the type
of attended is a
equal to
string,
string, we make sure that type of
and
always return is now
you
a
recall that it's going to
string. A bag of constants as a
just
string.
double check here. Yep. We recall that
Right.
we need to make sure that we're not getting an empty string coerced into a 0, because that's not the same thing as somebody typing in 0 here. So that's a little corner case that we want to take care of. So we're going to say if type of attended is a string, and we're going to use our little
And
friend trim again,
The
and
attendant
attended dot
trim.
is not equal to empty string. So we don't want any white space only or
So
empty
this is to
strings
actually handle
fit
is a
in
white
there.
space.
But
only.
if we have a non-empty string, then let's go ahead and try to make it into a number. So here we could say attended equals number.
So I want to now
Now here's where I
coerce that
diverge a
into-
bit from standard crowd that, for example, like static typing, because they don't like to
What
reassign a
we
variable.
can do here is that we are now is reassignment here. So this is something that you might not want to do in a functional programming. You don't want us to modify is the outside world. So what you can do is to say, hey, let me now return let me copy this object here. All right, and then I'm going to coerce that.
To its new type. I think this is a perfectly valid example of reassigning variables with a different type when you are explicitly changing the type for some purpose, like we are here. So that's one of the reasons why I don't like it when tools complain at me about reassigning over types. Okay, so we want to do the same thing that we just did for a tentative. We also want to do that for the length variable. So I will just duplicate that and change.
Exactly. So here we're going to check if this is now a type of a string, and that we don't handle is the corner cases where we say, hey, if this is an empty string, it will turn that into a false. You know, it will turn that into a false, so it will never be considered that. This is when now is the empty string is the root of all evil, especially here in JavaScript.
To length. We could probably factor that out into a function, but who cares? Okay. So now we know that if it was passed in as a string, it has become a number. If it was a number, it's still a number. But we don't know that you might have passed in something like null or undefined. So we still actually need to check that both of these are numbers before we do something. So our check needs to first say if the type of attended is number and the type of
the length is number.
If either one of those is not true, we're going to bail out, right? So here is our if statement, and then we're going to bail out, and that means we end up returning false. This didn't pass the validation.
Exactly.
But there's more that we need to check besides just the fact that they are numbers. If you recall in the README, it said we want to make sure that they're treated as numbers.
To make sure
they need to be 0 or higher. So we need to check not only that they are numbers, but we need to also
not only
see
that they are numbers,
but also that the is greater than or equal to 0,
greater or equal to 0, and the length
is greater than or equal to 0.
Must be greater or equal to 0.
The README also says that they need to be whole numbers, meaning they can't be like 3.14 or 9.1 as in the test cases.
So also both of these numbers needs to be integers. So in other words, this is when math operation kicks in. Okay.
If you did a quick check on MDN, you might have found that there is a utility built into JavaScript specifically for this, and it's called number dot is integer. That tells us if we have a thing that is
have an integer.
Yep.
Okay.
I mean, I think you actually casted it as a number in the first part, right? So
yes,
they're always going to be numbers afterwards, probably.
They aren't, because if I pass in a null here, then it's not.
If I pass in a null here,
not going to go into this clause, and it's going to still be null here. So that's why I have to check to make sure that it's actually a number.
Oh, okay.
Right?
Because the first is to doing is a string comparison, all right, and then you have to do now the numeric comparison. We are handling is these two both cases.
We want to allow strings and numbers, but if you pass in anything else, you're going to fail the validation.
Yeah.
Passing in null fails the validation. Okay, so we're going to check to make sure that attended is actually an integer, and we're going to check that.
And the same for is now the length.
Length is actually an integer.
Is there?
That really literally just says doesn't have any fractional component on it. Basically, what it's doing, right? So checking that it's a whole number. All right, and then the final thing that the README says is that attended has to be less
than or equal to length. All right. And that's
since we definitely know we're dealing with well-formed numbers at this point.
Now that we're definitely know that we're dealing with well-formed numbers at this point, we can say, all right, now these numbers, okay,
don't have any nans or infinities or any of that other stuff, then it's a very safe check for us to simply say
here the attended
is
less or equal to the length at this moment.
So we've restricted the overall surface area that could have possibly gotten us into corner cases.
And the thing here is that we're doing all of these different checks, but because we want to verify is specific stuff here. So hey, this is now how you transform this to a string. The first argument the first parameter and the second parameter, and if both of them are what we expect, which is number, and if those numbers are greater than 0, and if they are now integers, and if they are less than that,
into what is a fairly straightforward set of checks
so
to
return
validate
here.
that what we're passing
So
in
here
what we
is
want
this
to be passed.
basic
And we're eliminating
silly
any of those
stuff
corner
here.
cases, like somebody passed in an array with a number in it or anything else bonkers like that, okay? If we have passed all of these checks, then we can return true, and if that didn't pass, then we can return false. Same thing as before, we could now refactor that to a single return statement. I just wanted you to get the point of how we build up those test cases. Okay, so let's now test this code over in our console, and we should get all trues now. So we'll run this code, and we get all trues. Yay. All right, so we've written a couple of validator functions. Point being, wanted to get you familiar with the idea of working with these primitive values and the ways that they can be coerced and still not go off the rails into those crazy corner cases. Protect yourself against those corner cases. There are, of course, lots of ways that you could have implemented either one of these functions. You might have, instead of doing a dot length or checking for something, you could have used a regular expression. But the spirit of this was use what we know about primitive types and about
You have to be careful with this regular
the checks
expression
that are
here
coercions.
as
Okay.
well.
As I've been making this case for coercion, one of the things that may have been floating in the back of your mind is, yeah, but the coercion problem that I have is not with the plus operator.
Okay, so that'll be all for this video. Take care. Bye-bye.